Alright, today we're just looking at translations of functions. We're going to go through a couple of things that are pretty straightforward, but the next lesson's a bit tricky, so make sure you're all over this stuff, and then I'm sure you'll be fine. I think I've hidden myself. Oops, didn't mean to go full screen. Okay, so an image of a function is produced when a translation or dilation is applied. We've done this a bunch of times before, but let's just go through a couple of examples here. So these are the kind of four types of graphs initially that we'll be looking at. Of course, this can be applied to any type of function, but yeah, here's four different types that we can work with. Translation of h units in the positive or negative direction of the x-axis, which means shifts left to right. So in this case, it would look like this: x plus minus h, y equals 1 over x plus minus of h, and y equals 1 over x squared plus minus h, and of course y equals x plus minus h squared. Oh, I've made a little mistake there, sorry, that should be x plus minus h squared. So that's kind of a base that we can use for any of these different functions. Of course, remember that it's always the opposite of whatever sign you're working with. So if we're moving in the positive direction, it would be minus h. In the negative direction would be positive h. So I know you've done that a lot before, so just remember that that's part of that, whereas this translations of x units in the positive or negative direction of the y-axis is a kind of direct translation. So this would become y equals the square root of x plus minus k, y equals 1 over x plus minus k, y equals 1 over x squared plus minus k, and y equals x squared plus minus k. So it's the same thing for all of those. Plus k would move, translate our function upwards, and minus k would translate our function downwards, shifting it downwards. So that's pretty straightforward. So find the image of negative 1, 5 after 2 units in the positive direction of the x-axis. So that's as simple as adding 2 to our x value. So negative 1 plus 2 is 1. And 3 units in the negative direction of the y-axis, 5 minus 3 is 2. So that becomes 1, 2. Again, 3 units in the negative direction of the x-axis, so that's going to get us to negative 4. And 1 unit in the negative direction of the y-axis will be 5 minus 1, which is positive 4. So again, pretty straightforward. We haven't really done many translations of single individual values, but that's just the way that it works. We're usually using functions going forward from here. So find the equation for the image of the curve with equation y equals f of x, where f of x is 1 over x, under a translation of 3 units in the positive direction of the x-axis and 2 units in the negative direction of the y-axis. I think you've seen these functions enough that you can probably just do this straight away. We know that we're going to end up with 1 over x minus 3. Remember, when we're moving in the positive direction of the x-axis, we've got to do minus 3 next to x. And then 2 units in the negative direction of the y-axis is going to be, I need to change that to negative direction, is minus 2 there. So this is just a bit of a formula that is useful to go through to make sure you're getting your transformations correct. We're going to look at this in a couple of lessons. But if we create a new function called g of x, and instead of using x in our original function, we change that to x minus 3, we get to 1 over x minus 3. Then our next step is we're going to create another new function of hx, which is g of x minus 2, and again applying that to our previous g of x function, 1 over x minus 3, and then we just minus 2 from there. So I know that looks a little bit confusing, but that's just the way that works, and we'll look at that in a few lessons time. So for each of the following functions, apply the translations of x minus 1, or that's a positive translation of 1 unit to the right, and plus 4, so that's up 4 units, and state any equations of asymptotes. So this is going to become y equals the square root of x minus 1 plus 4, no asymptotes there, y equals 1 over x minus 1 plus 4. and we've got an asymptote at +1 and +4. Y equals 1 over x minus 1 squared plus 4. Asymptotes again at 1 and 4. And y equals, well, that shouldn't be, sorry, d, that should be, and then y. X minus 1 squared plus 4, meaning that we've been translated 1 unit right and 4 units up. I'll just quickly do a little sketch of one of these ones. So if we were looking at this graph here, again, we'd always sketch our asymptotes first. So at x equals 1 and y equals 4. And it would look something along the lines of this. Of course, we'd state those intersections with the x and y axes. But those asymptotes, it never touches those values. So that's as close as we can get it. That's all we really need to do. This one, same kind of thing for the values here. So asymptotes at the same spot. So don't forget to state all of that important stuff. Again, we'd state our y-intersection, and that's what this one would look like here. So sketch those on your calculator if you want to practice them a little bit, but I think you should be able to pick up translations quite quickly. We're going to go into dilations and reflections, which gets a little bit trickier, so make sure you understand this stuff really well.